Okay, so we're going to talk about future compound interest and present compound interest. And they usually say like future value or present value. I could have technically wrote the word value in there. But they're two sides of the same coin, which is not a wonderful metaphor, but hopefully it'll make more sense when we get to the end of this. So we're just going to pull a question here. There's a guy, Jethro, and how much would Jethro now have to invest? So he wants to have $10,000 in the future, let's say. Okay, so he wants the future value. And actually, you know what? I took the wrong start to this. I'm not even going to start with that. We have to define a whole bunch of things. So if I say FV, that means future value. Let's start with that. Okay. If I say PV, present value is equal to that. And each of those have technically a little bit of a different formula. The future value is equal to usually they write a letter P here for principal. I'm going to put a P, and then that is with 1 plus, and I'm going to write this as the rate, interest rate, divided by, and I think he showed me how to do this. Yeah, way better. Don't know how to do it anymore. There it is. Future value divided by the compound period, and then your exponent is the compound period times, let's get another color in here, purple, by the years. That's not an X, that should be years. You know what I'm going to do? I'm going to do it in brackets. I'll go bracket times years. Okay, so that makes sense. This is pretty similar to the present value formula. PV is equal to, same idea, you have some principal, and you have a bracket 1 plus, and you got some interest rate divided by some compound period, and the compound period is times the years, but in this scenario it's negative. Okay, so the formulas are pretty similar. It's just you have a negative exponent or a positive exponent. But within those formulas, there's a whole bunch of things like what is P, what is R, what is C. Like I said it out loud, but we haven't defined it. So let's go over here and actually define them. Principal. And I can't remember if it's PLE. I think it's PLE. It's like the starting amount. So the amount of money that you're going to start to invest with. R is going to stand for interest rate. And I know sometimes they use I, but most of the time, I'll show you what I stands for. Interest rate. And C, which is our fuchsia, I don't know what color that is, maybe pink, is the compound period. And YR, a little more straightforward, it's just going to mean years. Okay. Is that all we used? Yes. What color haven't I used? Yellow. I think we didn't use yellow. We'll use this orange one. I'm going to call I. I is actually usually equal to R divided by the compound period. So a lot of times they'll write these formulas and they'll actually have I in the place of RC. Or they'll have N in the place of C times YR. I should write that one too for you so that you know them all because there are so many variations to this formula. We'll do it in gray. N, oh, I don't know what I was going for. Oh, there we go. N is equal to, oh, I didn't write compound period. A lot of talking to myself in this video, sorry. Is C times YR. So you may, and I'll reiterate the formula, you may see the formula written like this. They'll say something like, maybe they even write like letter P is equal to A 1 plus I to the power of N. Well, it's really important because N is actually two pieces of information multiplied by each other. And I is actually two pieces of information divided by each other. So we can either, and this one is a nice formula to remember, it's pretty simple, but we then have to remember, oh, I have to calculate this value and this value. We're a little harder, but it shows you all the calculations you have to make. So whichever formula you memorize, that's okay. The other side of this is these are pretty much the same formula, these two here. We'll talk about how I'm going to take this amount, we're going to move it to another page here. We're going to actually attempt a question using those ideas. So we're going to say Jethro, that guy, he wants 10 G's, $10,000, 3 years in the future. I'm taking out a lot of the language from the question. And it's going to compound monthly. Actually, there's a whole other set of definitions we didn't talk about there. At 5%. Oops, I have an eraser. I can just erase that. At 5%. So here's our question. It's kind of short formed here. So first of all, we have to decide what we're going to do. It says that he wants this in the future. Oh, and I didn't define it. How much should he invest now? So the question is, what are they asking us about? Are they asking us to calculate the amount in the future or the amount in the past? That's the first thing we have to figure out. What we can do is we can actually just use one of the formulas. I know I showed you two of them, but we can actually just memorize the future value formula. So I'm going to say future value is equal to, and instead of putting A or P, you can actually sneak this in, present value, because the principal is the present value. It's like the amount you originally start to put in. That's how much money I have now. So I'm going to sneak that in instead of the P, and then I'm going to write the rest of the formula the exact same. I think R was blue. Oh my, complicated this for myself. C was fuchsia, and then I'm going to write the C fuchsia there. Times YR. Don't forget your bracket. Okay. So I've kind of combined the two formulas into one. And that way, we just have to memorize one formula. And the future value formula is really nice because I don't have to write that negative exponent up there. The only thing is we have to understand how to like balance an equation, move things left and right. So let's take what we got here. This question is asking us, how much should he invest now? So the question is asking us about present value. So we know that whatever it is we're going to do here, it's an eraser. Well, that's a good color. That's what we're looking for. So in other words, the future value is $10,000. Great. So we're going to replace future value with 10,000. Okay. Present value, still what we're looking for. 1 plus R. R is the interest rate. Well, interest rate, it's a percentage. It's 5%. We actually have to turn that into a decimal value. So you just take the number and divide it by 100. And that's going to give us, actually I'm going to do it over here, 0.05, I'll tell you, okay? So plus 0.05. Here's the tricky thing. Compound period. It tells us it's compounded monthly. But what is monthly? There's so many different words that use this. Monthly is a little simple. If you understand English, it's a decent word to pick out. There's 12 months in a year, so it equals 12. But there's so many other words they use in this case. They may use annually. Not a commonly used word, but it just means once a year. Semi-annually or biannually, it's technically the same thing, equals 2 times a year. Monthly is 12 times a year. If they say quarterly, they mean 4 times a year. They can technically say bi-monthly. Actually, biannually is not the same as semi-annually. I misspoke there. Bi-monthly is every 2 years. Bi is like a bicycle, so there it is 2. So if it's every 2 years, it's actually 6 times a year. Weekly, there are 52 weeks in a year, so it's 52 times a year. So there's so many different words to actually understand here. So if you ever get a question and they're using a word other than these, you should ask, like, these aren't commonly, I don't speak to somebody and tell them about my bi-monthly soccer games like that. So it's just a weird way to describe stuff. But it's very common in the financial world to describe things this way, so we do have to kind of memorize those values. So luckily, monthly was a pretty simple one for us. Monthly is 12, so I know to use the value of 12 when I divide. But that also means I'm doing 12 times, and YR, if you remember, just stood for years. Well, in the question, they told us our years were 3, so we're multiplying by 3. So that n value, which is these two numbers multiplied together, it's talking about how many times over the course of this loan or this investment do you get paid? Well, we get it 12 times a year for 3 years. So when we multiply those two, we get 36. So this is anytime you multiply this number or you're calculating it, just think about, does that make sense in the amount of times they're giving me like interest or they're paying me? This one's a little more vague. You can get some really funny numbers when we do this. But this is great. We can go from here and solve everything. We're going to kind of work it out. Actually, you've already worked it out, right? If we put this together, I'll quickly do some small calculations. PV is equal to 1. And that was 41666 repeated, I think? Yeah. Sorry, there's 2 zeros in there. 2 zeros. Yeah. We ran into that little mistake earlier that caught us because we didn't convert. 00416 repeated. And then 12 times 3 is 36. So here's our amount. So normally you would have used present value to calculate this. So this has gone a little confusing. You're going, shrink a little, thank you. You're going, okay, well, it's not isolated. You always have to isolate your variable in mathematics, okay? Yeah, exactly. And that way we don't have to memorize 2 variables. You're 100% right. We can just divide everything. So, I mean, I can do the calculating right now on this side, and I would need a calculator. I don't know what this value is off the top of my head. I want to say you got it to like 0.8 something.
0.86097.
Is that what it was? But we also multiplied by a negative value when you and I had done it. So it's going to be a little different this time. Why don't you do it while I'm still kind of explaining this. The other thing I can do is I can just, because this is multiplied here, I can technically divide this side by that amount, like the 1.00416 repeated power of 36. And whatever I do to one side, I have to do the other, so I would divide by 1.00416 repeated to the power of 36. These two create a 1, or they're commonly known as canceling out. But then this becomes PV is equal to 10,000 divided by 1.00416 to the power of 36. And I got to calculate whatever that is. Did you get a value for it? 1 something? Okay. And I could have done that over here. I could have, we'll quickly calculate it. You told me it's, so I got 10,000 over 1.1614, a whole bunch of other numbers. I could have done this number on the right side and it would visually be nicer. I kind of moved the entire equation. It's the exact same process. But in the end, we get a present value of, I think your number is right, $8,609.76 approximately. Great. So what we did is we actually took the future value formula and we calculated present value. So I don't have to remember 2 different formulas. I just got to go, okay, I got to know 1 formula. But instead, when I get a question, I have to decide, are they asking me to calculate the present value? Or are they asking me to calculate the future value? So let's take this same question, but instead, and those are getting long, let's say this wasn't the last line. And the last line is 3 years in the 3 years investment. I'm going to say this is now an investment. My writing is terrible, so sorry. Compounded monthly, I'm going to change that for us. I'm going to call this bi-monthly. Oh my God, only me and you will be able to read this after. How much will they have in the future? Okay, how much will they have in the future? So that last sentence, completely changes everything. They're asking how much will they have in the future? Same formula. We're going to write it out again. I'll have to shrink a little here. So future value equals present value. And just to simplify so I don't have to write so many colors, I'm just going to go 1 plus I to the power of n. Since we've already discussed that I is a calculation and n is a calculation, you're okay with that? Yep. Okay. So because they asked us how much in the future, different question. Now what they want to know is we have to find FV. So instead what we would be doing is we'd be putting, there we go, $10,000 into the present value. 1 plus, we already have this calculation. I lied, I changed it to bi-monthly. Because it's bi-monthly, what are we dividing by? Do you remember?
12.
Monthly is 12, so bi-monthly means every...
6.
Yes, 6. So every 2 months. So we divide by 6, which also means we're going to multiply our years by 6. We have the years the same. They're going to be 3, and the interest rate was still 0.5. I'm just going to do 6 times 3 up here. So the future value is what we're trying to find. So the future value is equal to 10,000. 1 plus, so we got to calculate this. What is 0.05 divided by 6? It's probably going to be like 0.0082 something? 83 something?
0.0083 repeated.
3 repeated. Great. And then 6 times 8 is our exponent, is 18. So again, we're still working with that same formula, which is wonderful. It's like less for me to memorize in terms of formulas. And now we just got to calculate this all the way out. I'm going to jump it around this question. FV equals 10,000, 1.0083 repeated to the power of 18. I can't technically bring up a calculator. I just have to find it on the iPad. Let's keep you doing it because sometimes this thing's a mess. 1.0083 to the power of 18. And then we'll do it all in one shot. Whatever that number is. Yep.
1.1604.
1.16421. Okay, and technically, I gotta move that over. Technically, that's still times this 10,000, but I don't need to do the 10,000. I know there's 1, 2, 3, 4. Sorry, I don't need to do it on the calculator because there's 4 zeros there, so I know to move my decimal place 1, 2, 3, 4, and that's going to be my value. So the future value in 3 years will be 11604.21, which is $11,000. So they've earned about $1,604 in interest. So I use the exact same formula. It's a different compounding rate. Like this one was it was 6 times a year, which means you're not getting as much. If it was 12 times a year, you would have earned even more money because they're giving you more payments throughout the year. So a little different, but same formula, same things to memorize. We just have to decide, are they asking me about future value or are they asking me about present value?